This problem says find the exact values of the remaining trig functions if we know that secant of theta is 8, where our theta is in quadrant 4. So first I'll draw the angle in question. Alright, so in order to draw it somewhat accurately, this angle, I want to have a sense of the lengths of the sides. So secant theta is defined as 1 over cosine theta. So they're saying the secant theta is 8. So I have to replace the secant theta with an 8. Okay, then I would solve by bringing the cosine theta over to the left, and then I'll put the 8 down below, so we would get this, that cosine theta is 1 over 8. Now, cosine theta, according to SOHCAHTOA, is the adjacent side over the hypotenuse. So they're saying that the adjacent side here is a 1 and the hypotenuse is an 8. So that angle is going to end up being something like this. And if we draw the components of that vector that I just drew here, there's an x component, which is the cosine, and then there's a y component, which is the sine. Alright, so the angle that we'll get, put that here. Okay, so the cosine of that angle is the adjacent over the hypotenuse. So they're saying that the adjacent is like a 1 and the hypotenuse is an 8. Now, we have to find out what the missing side is here. I'll call it B. So according to Pythagorean theorem, if we do a squared plus b squared equals c squared, the adjacent can be side A, so that's a 1. And then side C could be the hypotenuse, that's an 8. Subtract 1, and we get that b squared is 63. So b must be the square root of 63. Now we have all the sides that we need in order to complete the rest of the problem. So according to SOHCAHTOA, sine of theta would be the opposite over the hypotenuse. So if this is our angle, theta is opposite is the b. So you put the radical 63 there, and the hypotenuse is an 8. For cosine, it's adjacent over hypotenuse. We actually already have that one. That's 1/8. Then we have the tan theta, which is opposite over adjacent. So that's going to be the radical 63 is the opposite, and the adjacent is a 1. So we'll have that. For cosecant, it's going to be 1 over the sine of theta. We already know what sine theta is here, so we could just flip it, flip the fraction. If they want it in simplest form, we'd have to rationalize that denominator. So I get that for cosecant, and then for cotangent, it's 1 over the tangent of theta. So we'll flip the tangent, make that 1 over radical 63. I'm going to rationalize that though and get radical 63 over 63. So now I'm going to consider the signs of each of these, because I've got the sizes of them all, but got to take into account the sign because we are pointing into quadrant 4. This is a place where sine is negative, cosine is positive, and tan would be negative. So sine needs to be negative, cosine's positive, tan is negative. Cosecant came from sine, and sine was negative, so cosecant's going to be negative too. And cotangent was derived from tangent, and that was negative, so cotangent should be negative too.